Hello everybody, I want to do a really quick video on reading micrometers and calipers. There are handouts in the first day handouts folder on my website that you can print out for instructions on how to read micrometers and calipers. But these are common tools that we use in the machine shop. We actually use it in this class. Of the two, the micrometer is more accurate than a caliper. And when I say more accurate, is most micrometers today can read to the 4th place decimal. Calipers can read to the 3rd place decimal. So depending on what your tolerance limit is, or your amount that you're working to, can depend on which tool you need to choose. Most of the time, the calipers are going to work fine. They work fine in our classroom for the type of tolerances that we're holding. When we're dealing in thousandths of an inch, we're dealing with the 3rd place decimal. So in order to understand when we're saying things like 5 thousandths, 10 thousandths, 25 thousandths, it's written like this. This is 1 thousandth of an inch, 20 thousandths of an inch, 36 thousandths of an inch. Sometimes you'll hear us abbreviate that. We'll say, take another 5 thou. That means 5 thousandths of an inch. But whatever number we say, it needs to end in the 3rd place after the decimal point. So in other words, 1 thousandth of an inch needs to have 2 zeros put in front of it so that it lands in the 3rd place. 20 thousandths needs a 0 in front of it. 36 needs a 0 in front of it. 400 thousandths can be written as 400 thousandths and end in the 3rd place, because this is our precision of 1 thousandths. Now, micrometers, being more accurate, reading them is fairly simple, but micrometers come in a range, meaning that all micrometers, the inch micrometers that we're using, come in 1 inch increments. So this micrometer here is a 0 to 1. It can measure from nothing to 1 inch. If I want to get something to read larger, for instance, this one here is a 3 to 4 inch. It still has 1 inch of travel, but it begins at 3 inches and then it can measure all the way out to 4 inches. So you'll need a whole set of micrometers, whereas on the caliper can span multiple inches in itself. So let's talk about reading the micrometer really quick. Reading the micrometer, I'm going to grab a 0 to 1 micrometer here. There's a couple of components that you need to be aware of. First off, there's this little lock right here. This micrometer should turn very, very freely. If it doesn't, it could be that this lock is on, so you want to make sure it's disengaged. Holding a micrometer, these are like right-handed tools. You want to put your pinky and your ring finger underneath what's called the spindle and the anvil so that you can operate the micrometer. A quick way to open the micrometer is roll it down your forearm. A quick way to close it is roll it up your forearm. I want to open it up enough that I can clean the surfaces, because it doesn't take much of a debris to throw these micrometers off. These are very precision pieces of equipment and they need to be treated as such. When you're taking a reading on a part, you also want to make sure that the surfaces that you're reading are also free of chips, debris, and also burrs, right? Those are the little standing pieces of metal that might be on there. You'll take your micrometer and you gently place it over your part, and you want to make sure that when you apply pressure for the measurement, you don't squeeze down. These are not clamps, so you don't squeeze down at all. You barely touch the surfaces. As a matter of fact, most micrometers today have this little friction band up here that allows you to put the proper tension on the micrometer. So this actually has a pre-tension, we'll call it like a torque wrench, and some of them have a little ratchet in that click. But this gives me exactly the pressure that I need, and once I have that, I can then turn the micrometer sideways and take my reading. Reading a micrometer is very simple. Look up at the board here. You have a breakdown on the scale. You have this static scale on the sleeve here. Each one of the whole numbers stands for 100 thousandths. They are subdivided into 4 25 thousandths increments. So when we're taking a reading for the micrometer, we take this static scale in combination with the scale that's on the thimble, and that will give us our singular thousandths. 1 revolution of the thimble is equal to 25 thousandths. So each time we read the micrometer, we're reading to the very left edge of this thimble. Look at this example here of 400 thousandths that's being measured. The left edge of that thimble would be right over the 4, and the 0 on the thimble would line up with the 0 on the sleeve, and that would give us a perfect 400 thousandths. All too often though, you're going to see something where the micrometer is kind of in between things, and you just need to do the simple mathematics in order to determine what the micrometer is reading. Look at this example here. I'm going to count my largest values first. So I see 200,000 showing, but I don't see the 300. So I just write down my 0.2 and carry the zeros out to the third place. I have one tick mark here, 25,000ths tick mark. So I'm going to take that as 25 thousandths, write it out, and get that 5 to the third place by adding a 0 in front of it. And then on the thimble portion of it, I have 12 thousandths lining up, and sometimes it could be off by just a hair or two. It's in between the 12 and the 13, or 11 and the 12. In this case, we're rounding to the third place decimal. So I would put the 12 thousandths, getting that 2 to the third place by adding a 0 in front of it. Then you just simply add them up vertically, bring down your decimal point, and this value reads 0.237. Micrometers can read to the fourth place decimal. We're not going to cover that in depth, but the fourth place decimal scale is here, and typically what you would do is you would read it to whatever closest number it came to. You wouldn't round up, you would round down, and then you would go to the side scale here and see which one of these lines lined up perfectly with one of the lines on this scale, and that value that was on the side scale gets transferred over as your fourth place digit. On a caliper, calipers, as I said before, can span multiple inches. But besides that, calipers can also measure differently than micrometers. The micrometers that we're using here are called OD micrometers. That means they measure outside dimensions. I need a different style micrometer to measure the inside of something. I need a different style of micrometer to measure the depth of something. With calipers, I can measure all of those things with just one simple tool. With this caliper, I can measure the OD with this part of the caliper here. I can measure the ID, the inside dimension of this hole, using the little ears on top here, and by pulling gently outward. With the caliper on this end here, this extension is for measuring depth. I actually have a small shoulder inside this part, and I'm going to place that depth gauge inside and then just gently bring the caliper down to the face, and I've measured the depth. And there's even a fourth way to measure the depth, and that is using the face of the caliper here, the end of it, and then the end of the moving jaw here, which are ground flat. And I have this shoulder on the outside of the part that I'm going to place the caliper on and then come in this way and read the caliper like so. Reading the caliper is very, very simple. It's just like reading the micrometer. You have how many inches are showing. In this example here, I have 1 inch showing. I don't see the 2 inch mark, so I write my 1 inch, bring my zeros out. Each one of these is equal to 100 thousandths. That's one revolution of this dial, and I can see that there's 8 of them showing. That's 800 thousandths, so I put that 0.800, get it out to the third place. And then finally, I read directly off the dial. The dial's on 57, so I get that 7 to the third place, and I add these up vertically, and I have 1.857. And that's as simple as it is. On your quiz, you will get a picture of a caliper and a picture of a micrometer, and you will need to read the fine print to see what size micrometer you're working with, whether it's a 0 to 1 or 1 to 2, 3 to 4, or so on, and you will need to determine what that value reads as one of your test questions. And the same thing with your caliper. You want to make sure that you read how many inches are showing, and then figure out the rest of it by counting out the hundreds and then the single thousandths. So that's just a quick, brief lesson on micrometers and calipers. And remember again, you can also refer back to the first day handouts and print out the instructions on how to read micrometers and calipers as well.